Okay, so the next type of example is, let's say they give you a diagram, they give you the forces drawn to scale, and you need to figure out the scale, complete the diagram, and find the resultant force. Okay, so how do you figure out the scale? Okay, usually, of course, if in O levels, they will give you the scale, a nice scale, but it's quite hard for me to do that. So the scale is not going to be nice, but the method is exactly the same. So basically, you just choose one force. Let's say you choose the 13 Newton force. You measure its length, right? So let's measure its length properly. Usually they'll give you a nice number, but in this case it is not, so it is 7.3 cm, right? So 7.3 cm represents 13 newtons. So what is the scale? 1 cm represents how many? Right? 13 over 7.3. That's right, equals to, you should get 1.78 if I'm not wrong. Yes, that's right. So I hope that makes sense to everybody. So if 7.3 cm is 13 newtons, then 1 cm is just 13 divided by 7.3, which is 1.78 newtons. So determine the scale. So if they ask you to write the scale somewhere, you write the scale somewhere. If not, you just write it here. So scale is 1 cm represents 1.78 newtons. Okay. Next, they ask you to determine the magnitude and direction of the resultant force. So now you just need to complete this diagram using the parallelogram method. So again, if you're going to do it, they've done a few steps for you. They have the crosshead and everything. What you need to do is maybe just estimate where's your resultant force going to be. It's going to be somewhere like that. Okay, then you draw your parallelogram. So again, turn the paper such that the force you want to draw is vertical. Take your sail, align the vertical sail, part of the sail, with the force. Take the boat, flush the boat with the bottom of the sail, hold the boat down, slide, hold the sail steady, and then draw. Okay, I'm gonna show you the hack that I said earlier. You draw first, erase later, but you must remember to erase. See, now I got a dotted line. Okay, next force, align the sail, put the boat, slide. Oh no, it wasn't long enough. Oh, it's just nice. Okay, so what I'm gonna do is draw first. Oops, I exceeded by a bit. So just erase that away. Just erase to make it dotted. Okay. Then my resultant force is from here to, so you see it's origin to corner of parallelogram, right? So origin to corner of parallelogram. Okay, then make sure you put in the double arrows. This is your resultant. Determine the magnitude, just measure the length. Say mine is about 9.8. Yeah, so 9.8, 9.8, 9.9. Okay, these questions, they have a bit of a leeway, okay? So 9.9 cm, so I'll just write 9.8 cm. And then my angle. Okay, so of course you can either measure from here to here, as long as you mark the angle, it's fine, or you can measure the whole big angle. I guess it makes more sense to just measure here to here. Look here, so 30. Yeah, it looks like it's right in between, so I'm gonna go with 30.5. I'll just mark this angle and say it's 30.5. Okay, as long as you have it in your diagram, it's good enough. So I need to find out how much is 9.8 cm. 9.8 cm is 1.78 times 9.8 equals 17.5. newtons. Okay, so your final answer is, so therefore resultant is 17.5 newtons. Sorry, my handwriting. 30.5 degrees from the horizontal as shown in the diagram. Okay, as long as you mark it clearly, the marker will understand, oh, you mean this from this side of the horizontal. Okay, this is how you do a question like this, where they give you the diagram, you need to determine the scale. After you determine the scale, you complete it to find the resultant force.